We are about to start the webinar. I see that people are still joining, so we give them another minute or so and then we get started. Good afternoon, everyone. Thanks for joining today's webinar on the Xpress Compute Interface. My name is Oliver Bastard. I'm heading the optimization product management here at FICO, and I'm joined by Dinek Kargade, who is product manager in charge for this new capability, the Xpress Insight Compute Interface. So we have recently launched this capability as part of the last release in early November. And what we're going to do today, we're going to introduce it to you, show you lots of demos and get you started with it. So what is this about? So it's basically provides you with the capability to manage and offload your often compute-intensive optimization tasks to remote service. And with that, I will give you first an overview of the Xpress stack. I see that many of you are already Xpress users, so I will keep this rather short. We have the Xpress solver engines at the bottom of this chart on the left-hand side. It provides our core optimization technologies with linear, mixed integer, nonlinear, and constrained programming algorithms. Then when you have such a solver, you need some way of describing your optimization model. You can do this in Mosel, in our modeling language, or you can use Python or pretty much any other language you choose to. We've listed Python here besides Mosel because it's really a first-class citizen in our stack. You can choose between Mosel and Python to then build your models, build your application logic, configure the Insight application, which then provides you with a business user-ready interface into your optimization model. It comes with scenario comparison, user management, visualization, all those good features. If you now consider such an optimization solution, you know that you want to run multiple scenarios. You do what if, efficient frontiers, probably some Monte Carlo simulations. So you need an ability to efficiently not only create and queue, but also execute and distribute those workloads. And so we have been developing this capability for a while. And as part of the recent work we're doing, we are re-architecting and restructuring our stack. And what we want to present to you today is exactly this component, this compute interface, which allows you very easy distribution of those workloads to remote machines. Could be directly from the console, through an API, through Mosel, Python, whatever you choose to, through REST API. So it's really flexible, and most of this you're going to see today. Just to complete the introduction of the stack, we have a Xpress Workbench. This allows you to build your optimization models and also configure your Insight applications, and the visual configurations are done with View Designer, drag and drop interface to create your user interfaces. And based on those components, you can build your models, your services, and your solutions. We welcome you to using any part of the stack to your liking. And with that, we are focusing now on the compute interface, and I hand over to Dinek.
Thank you, Oliver. So the agenda for today is I'll be introducing the Xpress Insight Compute Interface, the key capabilities, then give you a demo of some of the APIs and additional capabilities, and we delve into the technical details, what the integration options are, how you can deploy, what some of the queuing, resiliency, security features, and what you can do with the solver libraries for remote execution. So high quality data becoming increasingly available, we're seeing that optimization applications are growing in scale and complexity as finer details are being incorporated to build true to life models. So they're not just in sheer size, but there are problems that are hard and they have large search trees. And when viewed from an enterprise standpoint, we have a number of operations research experts and solution developers who are building these solutions. But in the end, we have hundreds of business users who are running these optimization-based applications. So this places a big burden on the compute infrastructure. So enterprises are making investments to their compute infrastructure, and this needs better management. So enterprises need the ability to scale and efficiently manage workloads on their infrastructure. Next, I want to talk about a few illustrative use cases. These use cases are not meant to be exhaustive, but just to give you an idea of what the use cases of the Xpress Insight Compute Interface are. The first one being, let's say that you are an operations research expert and you're developing models on your laptop. However, your laptop is not powerful enough to solve multiple large optimization problems simultaneously. What you might do in your normal workflow is that you would copy your files or clone your files on a separate server, run those files, and then download them to analyze results. So the Xpress Insight Compute Interface offers a seamless way for you to offload your solves to remote service, and I'll show that to you with an example. Another use case is, let's suppose that there is a software vendor whose platform is growing. The software vendor develops optimization-based applications, and they are looking to grow their platform. They want to add third-party developers to grow their solution suite, and they're looking for a secure, scalable, and reliable architecture that can manage these large optimization workloads. The third use case is that if there is an enterprise with multiple OR departments, each department focusing on a specific function, then if you're looking to consolidate your optimization workloads from multiple applications or developers and testers, Insight Compute Interface provides an answer to this need. Insight Compute Interface also enables you to develop lightweight client applications. For example, if you want to build a lightweight client application that runs on a mobile device, for example, and you want the ability to transact purely in data and without the need for embedding any native code. And you also want to architect in such a way that your model and static data resides elsewhere. This is made possible by the Xpress Insight Compute Interface. So what can you do at a high level with the compute interface? You can develop your models locally and execute solves remotely. This means that you can offload compute intensive optimization solves to remote servers. And we provide a wide array of ways in which you can submit jobs using the Xpress APIs, using a REST API, or a easy to use drag and drop user interface. This allows enterprises to efficiently manage usage and distribute optimization workloads. And the architecture is based on industry standard technologies. It's scalable, resilient, and secure. So how does the architecture look like? I want to present this first to you. We will revisit this architecture later after we have gone through a few examples, but I want to orient you to the architecture now. So this architecture is not new. We've had this architecture of a client-server architecture for Xpress Insight, but now we are extending this to tightly integrated with the solver. So you can have multiple client applications that are using either Express APIs, Express Workbench, or one of these client applications is submitting jobs through a REST API, or another application that is simply sending data to the Insight server. So all of these client applications send data in some form to the Express Insight server. Then Express Insight server schedules the jobs onto execution workers, and this is where the actual solves are being performed. Once the solve completes, the results are sent back to the Insight server, and Insight server knows which client requested the solve and forwards it back to the corresponding client application. So in terms of the core features, you can submit MPS or LP files for remote execution, and this is possible with either a REST API and a WebSocket API. You can seamlessly integrate with the compute interface with Express APIs, and I'll show you examples on this. You can outsource any solve. By solve, I mean sending off an LP solve or a MIP solve or a nonlinear solve. But this also includes tuning and infeasibility analysis. And all of this can be sent off for remote execution. We provide a compute interface app. This is a drag and drop interface for submitting MPS or LP files. As part of Xpress Insight, it comes built in with queuing, load balancing, and user management. In terms of resource management, we support multiple execution queues and also thread-based scheduling. And I'll talk about these topics in later slides in more detail. In terms of security, we support SAML 2 single sign-on, API credentials, and there is session management for the compute interface app. So delving a little bit deeper into the core features, you can submit MPS or LP files for remote execution, and this can be of any instance type supported by the solver. So it's LP, quadratic, mixed integer, quadratic, second order conic, nonlinear, and general mixed integer nonlinear. You can also solve constrained programming models remotely. This is made possible when you build models in Express Mosel. Mosel itself can be executed remotely in two different ways. For example, you can submit a Mosel file using a REST API to the Insight server for remote execution, or alternatively, you can develop your model locally, for example, in Express Workbench, and you can execute the solve remotely. All these supported solver APIs can execute solves remotely. And in addition, you can specify solver controls as part of the job. You can include a basis to warm start LP solves, include a MIP solution files to provide user solutions. You can run infeasibility analysis and perform problem tuning. And if you have multiple workers available, you can do tuning in parallel. So this reduces your model development and research time. A set of solver callback functions are supported, and I will be talking about this in more detail in later slides. Now I'd like to switch to a demo of how you can offload optimization problems for remote execution. The first is being the Xpress Insight Compute Interface app. So launching the Compute Interface app is as simple as going to the Insight server URL. The specific mode that I'm showing is a development mode, and here users log in with username and password. But if you enable single sign-on, you will be directly forwarded to the Compute Interface app. So for now, I'm logging in as an administrator. And once I've logged in, I'm presented with this app. So there are tabs for you to upload your problems. You can see the problems, you can see the job queue, and when you click on integrate, it takes you to the documentation. So let's go ahead and start submitting some jobs using the Compute Interface app for remote execution. So once I click on the Upload Job tab, I'm presented with this page. On the left, you configure your job. That means you can specify what type of problem you're solving, but you can also choose to use the default settings. You can choose the root algorithm to solve a MIP, or if you're solving an LP, you can specify what algorithm, LP algorithm, to solve the linear programming problem. You can choose what results you want to download after the solve completes. And there are two stopping criteria that you can specify. The first is the time limit and the relative MIP gap. In addition, you can specify controls in a comma separate format. For example, you can ask the solver to use a stronger cut strategy, for example. So now I have some LP files or MPS files here. All I'm going to do is drag all of them and drop them onto the Compute Interface app on the drag and drop pane. Now I can go and see that they are now executing. So I can cancel my jobs right from here. And once this is completed, the next job will start executing. So as an example, I've already solved one problem. I can go and see the job specifically. When I go see it, I see that the run log on the right. I can download this run log, but also I can download specific results. The results that I specified that I'd like to download in the Upload Job tab. And you can download the payload itself, and the payload corresponds to the MPS file that you just submitted for execution. So I'm going to cancel the remaining jobs for now. And next, I'd like to show you how you can offload solves using Xpress Workbench. So what I have here is a formulation of a generalized assignment problem. It reads data from a data file called testdata.dat. And my main Mosel model is called main.mos. In this problem, I would declare my variables, objectives, formulate the problem, and you see that there's nothing specifically different that I'm doing to solve the problems remotely. So when I run the model, you'll notice in the log something new that you might have not seen before if you're a current existing user of Xpress. What this is doing now, you'll see in the log, is that this job is being sent off for remote execution. It creates the timestamp when it is submitted and creates an internal ID, and the execution mode is called compute. So it has been sent off for remote execution. So this job is now will appear on the queued job if it is executing. This specific problem is small enough, so it's already completed. And the log now you can see through the Compute Interface app. And again, I want to emphasize that there is nothing specific that I've done in terms of changing the code in Mosel. All I've done is change some configuration settings behind the scenes. And I'll talk about that in the coming slides, the exact configuration settings that you need to enable the remote execution. Now I want to switch to another example here. Here I have the console optimizer. I launch the optimizer through the command line, and you'll see something different if it has been enabled for remote execution. You'll see that the console optimizer also launches in a compute mode. And my workflow remains the same, nothing changes. So I have a problem arrow 4, and I read it. This problem arrow 4 is on my desktop. I can set a control. So for example, I set my max time equals my 30 seconds, and I solve. So as soon as I invoke a solve, which is MIP optimized, the problem has been sent off for remote execution. The problem is executing on the remote server. And while the problem is executing on the remote server, you see the log live on your local desktop. So once it's completed, it appears in the finished jobs section. So now next, let's see how we can tune this problem using the Xpress Insight Compute Interface. So for this specific case, let me reread the problem again. And I want to next show you how to perform tuning. So for this, I want to set tune the threads to 4. I want to use no more than 3 threads. And for the purposes of this demo, I don't want to spend a whole lot of time tuning, so I will set my tuner max time to 30 seconds. So now I invoke the tuner from the console. It is sent off for remote execution. And because I'm asking that the computer interface execute 4 problems at a time, the tuner then starts tuning, and you see that the problems are being sent off for tuning, and 4 problems are executing concurrently on the workers. So in this manner, if you're developing a model and you want to tune your instances, see what controls work best, this is easily done with the computer interface. Nothing, your workflow remains the same, and your experience will be seamless. So now that we've seen how tuning can be done in parallel, let's also see some other use cases. One where I'm using the C++ API. Here, I want to demonstrate how you can take advantage of the compute interface to solve your problems in parallel. Let's say you're writing a decomposition algorithm where you have a number of subproblems, and you'd like to solve the subproblems in parallel, given that you have multiple machines available. And again, this is made possible by the compute interface. So in this specific example, I initialize Express. I get some subproblems, and I spawn 12 threads. And in each thread, I solve an optimization problem. So let's see how this works. So I'm spawning 12 threads, and I have the capacity to solve 4 problems at a time. So let me kick off this run. So this is kicked off here. Let's go ahead and see how this works in the compute interface app. So all the problems have been sent off for execution. I'm allowed to execute 4 problems at a time because that's my current capacity. And the problems from the remaining threads are queued and will be solved as soon as the workers become available. So yeah, and some of them have finished, and now you see that the next set of jobs are queued for execution, and this will continue until all the problems have solved. So if you want to parallelize some of your code and solve your problems, decomposition problems faster, you can do so with the compute interface. So I've mentioned earlier that all you need to enable remote execution solves is a simple configuration. And the configuration is that you get your credentials. So you log into the compute interface app as usual. So this provides you with, you get your credentials from here. And once you get your credentials, you copy them and store them in a secure location. you can enter these API credentials into your credential store. In this specific slide, I show you how to do this on Windows. On Mac, it's similar. You store these credentials in your keychain access. So you add a generic credential, you then specify the URL of the Insight server, and using the API keys that you obtained from the Compute Interface app, you store them here. Now, these credentials can be revoked, and anytime you revoke them, these credentials must be updated. In addition, there's one additional small step. You specify the environment variables. There are two environment variables. One is called Express Compute. You turn it on, and this will enable remote execution. And then you also have the Insight server URL. So if you don't want to specify system-wide environment variables, you can also set these environment variables locally. And let me show you just one example here in Express Workbench. Here you can specify these environment variables here. And what this does is if you have, let's say, a local license, but for this specific session you want to offload your solves, you can do so by specifying the environment variables here. So moving on to the technical details, as I promised, I want to revisit this architecture diagram again. So what we just saw earlier was you have multiple different ways of integrating with the Xpress Insight server for remote execution. What I demoed first was the Compute Interface app. As soon as I dragged and dropped MPS or LP files, they are sent off for remote execution to the Insight server. Insight server then schedules the job onto workers as they become available. Another use case was I was running it from Xpress Workbench, a Mosel file, and that got sent off for remote execution. The third example was I was doing tuning and also submitting jobs with the console optimizer. And the fourth use case was I was using C++ and solving problems in parallel. So this is all unified and seamless in that there is no code changes or no special API functions that you need, just a behind the scenes configuration. And once that's turned on, you can start offloading your solves to remote workers. So with the compute interface, you get a number of integration options. If you have existing applications, if you have code that already uses the Xpress Solver APIs or Mosel, you can turn on remote execution without any code changes. So this is recommended for data science and operations research use cases. So if you have Xpress libraries and you have built an application on top with Xpress APIs, with the simple configuration, you can send it off for remote execution. We also offer a REST API, and this is recommended for building transactional systems with a generic REST client. So any language that's, with which you can submit REST requests, you can do so. So you can build applications along this vertical. And finally, if all you need is a quick way to to solve your problems, you're in your R&D phase, you have a number of LP files that you have lying around that you want to test quickly and see what the solutions are, you can simply drag and drop them with the Compute Interface app. You can integrate with Xpress Solver with the language or API of your choice. This means C or C++, Python, Java, .NET, and also the modeling capabilities, which is BCL. The REST client, so the Insight server exposes a REST API. So this is to a compute endpoint, you can submit LP, MPS, or Mosel jobs. But also you can submit just purely data files. And along with that, you can specify what the configuration should be. After you submit, you can then query the status of the job. You can ask Insight Server how far along the job is. So whether it's executing, whether it's completed, or if due to unforeseen circumstances, if the job might fail, you can ask Insight Server, and Insight Server will tell you what the status is. If the job completes successfully, you can get the results, you can get the run log, you can read the documentation, and there are more functions that are available through the REST API. You can also monitor your progress real time. This is made possible with the WebSocket API, which extends the REST API. You can get run log updates live, and also the WebSocket API is the foundation for us supporting callbacks during remote execution. So the compute interface comes with the Swagger docs, and you can try out your REST calls with the Swagger docs directly. The specific case I'm showing you the compute specific endpoints and how you can post a job. You can get the details of a job, and you can also delete a specific job from the database. Another architectural pattern that is supported by the compute interface is that you can build lightweight client applications. So you can transact purely in data, and there is no need to embed any native code. Let's say that you're building a client application that is browser-based. For example, the browser processes online transactions, and you need the browser or the client applications to be lightweight. What you can do is, and let's say that your application also now supports optimization under the hood. It does some optimization solving. Instead of embedding native code on your client, you can simply use the REST API. So the workflow would look like this. The model developer develops a model in Mosel, and you can upload supporting files as attachments to Insight. So the Mosel files and any supporting files are posted to the Insight server as attachments. Now, the browser or the client application can send just data to the Insight server while referring to these files as dependencies. Insight server subsequently unpacks all this information and sends it off for execution. Now, Mosel also supports reading and writing to a wide range of data formats. This includes JSON, CSV, XML, flat file, and so on. So once the execution is done, you can, with Mosel, write out data in the format that you want, for example, JSON, and that is sent back to the client, and the client can render it or use the JSON file in the way it likes. So in this way, you can build lightweight applications. So there is no embedding of native code on the client, and you can develop lightweight client applications using this architectural pattern. In terms of deployment, we are currently supporting two deployment options. Typically, this would be a local or standalone deployment where Insight server and execution workers are on the same location. Another option is a single Insight server with multiple execution workers. This would be the more standard deployment. In terms of databases, as soon as you install it, out of the box, you get a lightweight file-based database, and this is recommended for non-production usage. And we also offer support for your self-managed, highly available MySQL database cluster. Next, let's switch to how resource management is done. So how can you manage your infrastructure with Xpress Insight? So again, I want to emphasize that this is not new, but what's new is the remote execution capabilities. So this has been part of standard insights. Some of you might already be familiar with this, but I want to demonstrate this anyway. So let me switch over to the admin tab of my Compute Interface app. So not all users will have access to administering the execution services, only specific users. So you can add an execution worker by adding this button. So if you're adding a new machine to your network, then you can specify that with adding this new execution worker. An execution service is a logical grouping or a logical partitioning of servers. And I can specify multiple execution services. Here I have two services. One is called primary and the second is secondary. And I map my workers to specific execution services. So in the specific case, my primary execution service maps to the specific worker, and I can also specify what my thread capacity for that specific worker must be. So how does this execution servers and execution services help manage your infrastructure? And I will talk about this next. So once you have configured your execution services, you can then specify to which execution service a job must be routed to. So this enables multiple queues. And you can specify which execution service a job must be submitted to either via a configuration, a one-time configuration, or as a part of your job, you can specify a control called compute exec service. And you can designate that the specific job be sent to either a primary service or a secondary service. Or if you have more services, you can tell that the job should be executed on the specific service. And why might you want to specify multiple services? The use case is, let's say that you have jobs that take a long time to solve. You can specify that they be solved on this execution service. And this execution service contains two workers. On the other hand, if you have jobs that are small coming from an application, and these are fast, you can then designate that these be solved on a specific worker. Another use case is you can separate production versus test workflows. So on this queue, you can just queue up production workloads. On another queue, you can set up QA workflows. So you can partition your infrastructure the way that best suits your optimization workloads. In addition, we also support thread-based scheduling, so which means that you can ask that the jobs be scheduled on workers that meet a minimum thread capacity. So if there are multiple execution workers within a specific queue, but let's say this worker has that minimum thread capacity, then this job will only be scheduled on the specific worker. And as we have seen earlier, Insight manages this job queue. And as workers become available, they start getting scheduled onto them. And once they're finished, you get to see them on the finished job pane. So Xpress Insight also offers user management in local or development mode. Administrators can add or remove users. For example, let me go here and go into the users tab. I can add a new user. Here I have 3 users, one being the administrator. But if you are on single sign-on, in this case, the ID provider assigns the compute interface app to the user. So administrators cannot create or delete users under single sign-on. Administrators can also assign user privileges. For example, you can restrict or allow users to configure execution services, or you can prevent users from modifying, downloading, or deleting any attachments to Insight. Xpress Insight also offers resiliency features. So if jobs have failed, for example, if a worker goes out of memory, they're automatically retried once. And if the worker loses connection to the Xpress Insight 5 server due to any network issues, then Xpress will attempt to reconnect to a running job. And this a specified number of times, but if it does not within the specific time, then the job will fail with an error. So in terms of authentication, as I mentioned earlier, there are two ways where you can authenticate. In the standard or enterprise use cases, the single sign-on is recommended. The compute interface app must be assigned to the user. And if it's ID provider initiated, that means that if the ID provider has a list of apps, you go to the list of apps and you can launch the compute interface app from that list. Alternatively, if you directly try to access the compute interface app, then Insight forwards you to authenticate via single sign-on. In local or development mode, you use your username and password. Console and solver library users can be authenticated with Credential Manager on Windows and Keychain Access on macOS. And the credentials are obtained from Xpress Insight, as I showed you earlier. For the REST API, authentication is done via bearer tokens. And this, you do a post request with the credentials from your Xpress Insight app, and Xpress Insight will return a bearer token, which you subsequently use for all communications with the Insight server. Also, Insight offers security features. We talked about single sign-on earlier. You can enable HTTPS on the Insight server. And the sessions are managed. You're logged out of your compute interface app after it reaches a maximum age of 8 hours. And this is configurable using a config file. And if you have inactivity on the compute interface app, you're automatically logged out. The bearer tokens, if you're using the REST API, they default to 15 minutes. And there's a mechanism to refresh this bearer token. But this the short-livedness can be configurable up to 60 minutes. So in terms of solver libraries, I want to talk a little bit more in terms of the details as to what functions are supported in remote mode. Anything that you invokes or involves a solve can be executed remotely. So this includes LP, MIP, or nonlinear solve. You can perform infeasibility analysis remotely. You can also do repair infeasibility. This means you can, if you have a problem that is originally infeasible, but you want to compute a solution by relaxing bounds or constraints, then this can also be done remotely. Tuning, as we saw earlier, can be done remotely, and all the solves that are being done from any of these APIs appear in the compute interface app. A certain subset of callback functions are supported in the remote mode. These include the logging callbacks, so LP, barrier, global, and cut log logging callbacks, and also the gap notification callback. This callback is fired when a pre-specified gap is reached. And also supported is the integer solution callback, and this callback is fired whenever an integer solution is found. So I think we have some time, so I'd like to demo this example with the integer solution callback using the Python API. What I have here is that I'm reading a problem from disk, and I add a callback function. The callback function's responsibility is to collect the solutions, but also I want to terminate my job after it reaches or if it satisfies a specific criterion. And the criterion that I have specified here is that if 15 seconds have elapsed, at least 15 seconds have elapsed, and I have 10 solutions that I've found, and I've reached 5% optimality gap, I want to stop the solution. So now let me run this example. What is happening here is that the job has been sent off for remote execution. And while the solve is happening remotely, the callbacks are fired. And in fact, if you set a debug breakpoint here, you can in fact even see that how the solutions are found during the search. So in this way, although the solves are happening on a remote machine somewhere else, you can programmatically terminate the solve. So 10 solutions have been found. My gap has reached below 5%, and I've programmatically decided that's good enough for me, and I stop the solve. So inside the integer solution callback function, a couple of API calls are permitted. This is getMapSolve, which returns the integer solution. This is equivalent to calling the LP solution because an integer solution has been found. No other API calls are permitted during remote execution, except you can set controls and you can also interrupt a solve. If you have more advanced use cases that you like to solve remotely, for example, you want to implement your own branch and cut code, or you have specific your own branching schemes, and you want to implement these complex callback functions to be executed remotely, you can develop and implement these models and algorithms in Mosel, and you can submit them for remote execution. So in summary, Xpress Insight Compute Interface enables remote execution of Xpress Solver and Xpress Mosel. You can develop models locally and execute solves remotely with any API supported by the solver. You can outsource any solve. This means tuning and feasibility analysis. And there are a wide array of integration options. And this makes it all seamless because no additional code changes are necessary. And also you can architect lightweight client applications with the help of the REST API. With Xpress Insight, you can manage your resources efficiently. You get queuing, load balancing, and user management. You can create multiple execution queues and also schedule your jobs based on the worker's thread capacity. We get resiliency features, so jobs are retried if they fail. And also the Xpress workers can reconnect to the Xpress Insight server if there are any failures in the network. You get security, SAML to a single sign-on, you get API credentials, and sessions are managed that you're logged out of the apps. And you also have short-lived bearer tokens, which means you have to refresh them depending on how you have configured the timeouts. And with that, I can take any questions.
So thanks, Dinakar. We have a Q&A panel where you can ask questions, and I see we've also received some other questions through the chat, but I think the Q&A panel is preferred.
Yep, so there's a question that asks, can I use Express Python API, the local machine without license to model the problem and send it to a remote server with install optimizer? Yes, you can precisely do that. So any of all of these remotes for executing solves remotely, you do not need a local license. All you need is to configure your applications and APIs correctly with the environment variables and API credentials, and you can send them off for remote execution.
So then there's one on how's it with licenses. Do I need both an Insight and Express server license to run this? And you need an Express license on the execution side, and you need a specific Insight Compute Interface license. So it's not a user-based Insight license, it's a specific capacity-based Insight Compute Interface license.
So there's a question that asks, how do I send the environment variables, express config variables when running a REST call? Again, there is no specific configuration that is needed. You can directly submit your jobs via the REST call to Insight Server. However, you need to be authenticated. So once you submit your API credentials, the Insight Server will return with a bearer token. And with the bearer token, then you can, in subsequent communications, you can use that to authenticate and submit jobs. So another question is, why can't we run jobs on the server? Why do we have execution the server in the middle? Is it so for letting the job decide where to run? So the exactly the Xpress Insight server manages and the architecture. So let me switch back. To the architecture here. This need not be a separate location. This is a logical representation here. So the server could also be a worker. These need not be specifically different. I've illustrated in this manner so that it becomes sort of easier to understand the separation of responsibilities, if you will. That the client submits the job, it sends to a server, and the server is responsible for scheduling the jobs. And the server and workers can be co-located. So it appears that I was demoing the entire stack, including remote workers, as locally learning services. Is that correct? Yes. Yeah, I have set up the server, Insight Server and workers locally. So it's a standalone installation. So how have I multiple workers running locally? So the way I've done it is I'm allowing 4 concurrent solves. So let me go back here. So I'm allowing 4 concurrent solves, and on my local machine, I have a thread capacity of 12. Steve, can you please give an example of configuration file for remote execution using any programming language API? So I cannot do this immediately, but as part of our installation, you get a software development kit that gives you examples of how to use the REST API with Python, Java, .NET, and so on, and even with Express Mosel. Are there any other questions that I missed?
I think there's one, the second one in the Q&A. Did you respond to that? So can you please give an example of a configuration file for remote execution using any programming language API?
Yeah. Okay. Yeah. So let me switch here. So I suppose the question was, what does this config file mean? I'll have to dig it up. So the only two environment variables that are mandatory are Xpress Compute and Xpress Compute URL. This config file is optional. It sets some additional parameters. There is nothing specific that is mandatory as part of this. I can set the logging level. Let me see if I can pull it up. So all I'm setting is a specific log level, and all that this JSON file is asking is the logging level and for whether I want to clean up jobs automatically, and that's it. And this file is optional. There is no specific need to even include this. Is there a breadth to version compatibility between parts of the stack, such as Workbench, Mosel, and execution workers? So yes, this version of the Insight interface is based on, compute interface is based on Xpress 8.11. And there's an Xpress Insight 5, which is an upgrade from Xpress Insight 4 series, during which we are launching the compute interface. So a couple of minutes left. Happy to take any further questions.
Cool. I think there was plenty of content and quite a few great questions as well. Then just one final question. So the Insight Compute Interface on this new architecture is GA. So yes, the interactive version, so what you currently view as Insight, so Insight 4 is not yet GA. That is planned for the next calendar year. But what you've seen today is all GA. Great. Yeah, then thank you. Thank you everyone for attending today, and thank you Dinaka for the great and exciting presentation. If you're already a user or you're interested in using this, please reach out to us. We are more than happy to provide you with evaluation licenses of this capability. Cool. Thank you. And yes, we have recorded the session, and yes, it will be made available. So that was the last question we just received. Okay, thank you very much.
Thanks, everyone. Have a nice rest of your day.